Hey guys, welcome back to one more video on the channel. So this time I'm back with a lecture series. So we have already done a lecture series for circle and now we are going ahead with one more conic section. So this is going to be a lecture series for parabola and this is the first episode of this particular lecture series. And I really want the session to be interactive. So YouTube has introduced a new option where you can add quizzes in your videos. So while explaining the concepts of parabola, I'm going to ask you a few questions and I'm going to add them in the form of a quiz. So make sure you take those questions for better understanding of the concepts. So let's make this session interactive and learn together. All right. So let's dive in. So this is our first episode, and in this episode, we are going to understand the definition of parabola and how a parabola is generated. Why is it called a conic section? How is it understood as a locus? And the important terminology related to parabola, standard equation of parabola, and standard forms of parabola. So if you're someone who wants to understand conic sections, if you're someone who feels that the questions that appear on JEE mains are advanced from the conic sections part is difficult, so these lecture series will help you. I have already done it for circles. Go back to that lecture series if you have any queries about circles and make use of it. So let us go ahead. Now let us first see how a conic section is generated. I mean, like how a parabola, ellipse, hyperbola, any conic is generated. All right. So you have one line L and you have another line M which is inclined at an angle alpha to the line L. So here this line L is called axis, all right, and okay, fine. So you have these two lines now, and by keeping the line L fixed, you rotate the line M without changing the angle alpha. Then you will get something like this. So what is this shape? This is a right circular hollow cone and it has two napes. So upper nape, so the upper cone is called as upper nape and lower cone is called as lower nape. So the figure that is formed by the rotation of this particular line M about the line L is called double napped right circular hollow cone, and this is a very important figure which is needed to define conic sections. All right. So, and again there is a terminology here as well. So this is called as lower nape and this is called as upper nape, and this M is the line because of which this double napped right hollow circular cone is generated. So hence this is called as generator line and this L is called as axis, and the angle between generator line and axis is alpha. So this is the terminology related to double napped right circular cone. Now to get any conic section, any shape, you need one plane. So let us say this is that particular plane. When you cut this shape with that plane, let us say the angle made by this plane with this particular axis of the double napped right circular cone is beta. This is that angle. So now depending on the value of beta, you will get different types of conics. All right. Now for parabola, a parabola is formed when the angle alpha is equals to beta. So the angle alpha is the angle between the axis and the generator line, this angle, and the angle beta is the angle made by the plane which is cutting this double napped right circular cone with its axis. When these two angles are equal, you will get a shape called parabola, and this is how it looks. So we are cutting it, and this is the angle between the axis and the plane which is beta. If this alpha is equals to beta, you will get a parabola. So this, you can see this in this particular figure. So I've added this figure. So if you see, so this is the plane that is cutting your upper nappe. All right. So when you cut the cone, so this part is left out. This part will come out. All right. This part will be detached from the upper nappe. Correct. Once the part got detached, so you can start on the surface of this part. All right, and just trace out the figure on this particular plane. Imagine that plane is a paper, and when you do that, you will get this particular shape, which is your parabola. I hope you have understood. A little bit of imagination is needed here. So if you want to clearly see these things, there are a lot of YouTube videos which you can pull out and see how the cut is happening and how the parabola is getting generated. So this can be easily done using MAINS scripts. I can maybe some day generate a animation and post it here if you guys really want to see how the cutting is done and how the tracing is done, in order to get the shapes. So now when alpha is equals to beta, you will get this particular shape. So thinking about hyperbola and ellipse is a little difficult thing here. But can you guys let me know when, like how do you have to cut this upper nappe or lower nappe with this particular plane in order for you to create a circle? So this is an easy thing, very easy thing. A basic, you know, a basic imagination of shapes should, you know, give you an idea as to how to make a circle using this particular plane. And also think about, and also I have one more question. How should you cut this particular shape using this particular plane in order to get pair of straight lines? So I've added these two questions in the quiz section. So let me know your answer from there. All right. So yeah, that is how a parabola is generated. When your alpha is equals to beta, it will be generated. So why, like if you want to know the proof of this, I mean, like I can prove that, but that is beyond the scope of JEE and you don't need that. So just to have a basic idea of how these shapes are generated, keep this in the back of your mind. All right. So now let us proceed. So we understood one way of creating a parabola. So now what is the another way? So how is it dealt as a locus? So let us see that. So let us say there is a point S. This is fixed point. And let us say there is a fixed line. All right. So, and let us say there is a random point P. Now, when you have these two lines, let us say the distance between this random point P and the fixed point S is SP. And and let's say the distance from P to this particular line is M. All right. Now, depending on the ratio of SP and PM, we get different conics. So we represent this ratio as E. E is called as eccentricity. That is the mathematical name given to it. All right. E is called as your eccentricity. You have a fixed point, you have a fixed line, and you have a random point for which you have to find the locus. So the distance between these 2 points is denoted by SP. The distance between this point and this line is denoted by PM, and this ratio is named as eccentricity. Now, if your eccentricity is equals to 1, you will get a parabola. So what does that mean? If eccentricity is 1, it simply means that SP is equals to PM. So this distance and this distance are equal. So a parabola is defined as a locus of all points such that the distance from the focus, this fixed point is called as focus. The distance from focus is equals to the distance from directrix. And what is directrix? Directrix is this particular fixed line. So let me repeat the definition. A parabola is a locus of all points such that its distance from the focus is equals to its distance from the directrix. So that is called as, that is the definition of parabola. If your eccentricity is 1, you'll get a parabola. If your eccentricity is greater than 1, you will get hyperbola. And if your eccentricity is less than 1, you will get an ellipse. And if your eccentricity is equals to 0, you'll have a circle, and your eccentricity is infinite, you will get pair of straight lines. All right, pair of straight lines. All right, so these three are pretty straightforward, but proving that the eccentricity of a circle is 0 and eccentricity is infinite for pair of straight lines needs little critical thinking. I'll explain it in some other video if you guys want to understand, but for now you can but for now you know that the eccentricity of a parabola is equals to 1. So now we understood what is the definition of parabola in terms of locus of a point. All right, so now let us try to derive the equation for parabola. So again, we have a fixed point S here. All right, fixed point S, and we have a fixed line. So when you have a fixed point, you have to give the coordinates for that point. So let us say the coordinates are alpha and beta. Again, when you have the fixed line, you have to give the equation of that line. So let us say the equation is ax plus by plus c is equals to 0. Now you have a random point P, and you know that for a parabola SP is equals to PM. So SP is equal to PM. So this random point is the point for which we have to find the locus. And since we are writing this particular condition, it will force this point to be on parabola. All right. So now what is SP? SP is simply the distance between 2 points. X minus alpha whole square plus y minus beta whole square is equals to PM. PM is the perpendicular distance from this point to this particular line, which is your directrix. So that will simply be ax plus by plus c upon root of a square plus b square. All right. So this is the equation of a parabola. Or if you, so we already know SP by PM is equals to E for any conic. So therefore SP is equals to E times PM. So if you put E here, it will become a generic equation for a conic. All right, for parabola this E is equals to 1, for hyperbola it is greater than 1, for ellipse it is less than 1. So this is the generic equation of a conic section. All right, now let us understand some terminology about these conic sections. Like, again, what I would like to point out one thing. So whatever I am explaining here is not something new or something that I have created. These things are taken from reference books. I'm just explaining the book. So there might be people who might not be able to understand all the concepts by just reading a book. So I'm just putting them all at one place so that people will be able to go through and understand. And maybe if wherever needed or wherever I feel it will be useful to the viewers, I'm adding my own insights. All right. So that is the purpose of this video. And do not come to me in the comment section and tell me that I'm just reproducing the content taken directly from reference books. So yeah, now let us know some important terminology. All right. So the first one is axis. What is an axis of a conic section? So this is a line that should pass through focus and perpendicular to directrix. perpendicular to directrix. So if your parabola will look something like this, all right, your parabola will look something like this. This is your focus and this is your random point P and this is your directrix, and this SP is equals to PM. So now what is your directrix? Your directrix will be the line which, sorry, this is your directrix, this is your focus, and what is your axis? Your axis will be the line that passes through the focus and perpendicular to the directrix. So this is your axis. All right. Similarly, for ellipse, there will be one directrix this side and one more this side, one focus here, one focus here. According to the definition, the axis should pass through focus and should be perpendicular to directrix. So something like this. So this is your axis for an ellipse. Understood? And what is the axis for a circle? So let me know that in the comment section, or I have added a quiz question. Take the quiz and let me know that. Let me know your answer there. And the next thing is vertex. What is vertex of a conic section? It is the point of intersection of axis and conic section. So this is your conic section, in this case parabola, and this is your axis, and the place where these two intersect is called the vertex. This has, parabola has only one vertex, ellipse will have two vertices. All right, hyperbola will also have two vertices. All right, so this is your axis and this is the place where your conic section intersects with your axis. And the next thing that we are going to understand is focal chord. Focal chord. So what is a focal chord? Focal chord is any chord that passes through the focus. So you have your parabola something like this, you have directrix here, this is your axis and this is your focus. So any chord that passes through focus. So this endpoint should lie on the conic section, this endpoint also should lie on the conic section, and this should pass through focus. So this is the focal chord of a conic section. Understand? And next thing is latus rectum. What is latus rectum? Latus rectum, so this is latus rectum. So latus rectum is a chord that passes through focus and perpendicular to the axis. So this is your focus. This should pass through focus and it should be perpendicular to the axis. Such a chord is called as latus rectum. All right. And the next thing that comes is center. What is the center of a conic section? Center of a conic section is that point which bisects every chord. Bisects every chord. So if you consider a circle and center, if you draw a chord passing through the center, it bisects this chord. Similarly, in the case of ellipse as well, so this is your ellipse, this is your center. If you draw a chord passing through the center, it bisects this particular chord. No matter the length and no matter the place at which you're drawing, it always bisects the chord. So now I have a question for you. Can you plot or identify the center for the parabola? So if you see, parabola is this thing. So every chord should be bisected at this center. So if you draw a chord which passes through focus from here, so you can clearly observe this length is greater than this particular length. All right. So focus is clearly not the center of your parabola. So what is the center of the parabola? Can you identify that particular point? Again, I have added this particular question in the quiz section. Make sure you take the quiz. So the next, you'll get the explanations for all the questions that I have asked in the quiz section itself. All right. So the next question, the next thing that we are going to learn is the standard equation of parabola. So there are some standard forms of parabola which are used in JEE. So we are going to check one of the standard forms of parabola. So let us consider there is a focus on x-axis at a point whose coordinates are 0, a and 0, and the directrix is the line x is equals to minus a, and your axis is simply x-axis. So now with this information we can draw the figure. So axis is your x-axis. So the conic will be symmetric about the axis, so it will look something like this. The parabola will be symmetric about the axis, so it will look something like this. And the directrix is x is equals to minus a, it is given. So this point will be minus a comma 0, and focus is given as a comma 0. So this is S, and let us say since any point on the parabola, since for any point on the parabola this particular distance and this particular distance are same, this will be the vertex of the parabola and the coordinates of the vertex will be 0 comma 0. It will simply be the midpoint of these 2 points. So we found out the vertex as well. So now we are going to determine the equation of this parabola. So let us consider a random point px comma y on this. So now your SP will be square root of x minus a whole square plus y minus 0 whole square. This is equals to e times of x, e times of pm. So this is your SP, this is your pm. So e times of pm, but e is 1. So 1 times pm. Pm is simply x plus a upon root 1 square. So this is the equation of the parabola. Now square it on both sides. Then you will get x minus a whole square plus y square is equals to simply x plus a whole square. Expand it. X square plus a square minus 2ax plus y square is equals to x square plus a square plus 2ax. So this, these terms will get cancelled. So all you have is y square is equals to 4ax, and this is the equation of the standard parabola that we deal with in our JEE syllabus. So this parabola has the focus as a comma 0, and its directrix is x is equals to minus a, and its axis is x-axis. The vertex is 0 comma 0, and the equation is y square is equals to 4ax. So whenever you look at this particular equation, you should be able to write the vertex, which is your 0 comma 0, and the equation of the directrix, which is your x plus a is equals to 0, and focus, which is your a comma 0, all of these things. So now the next question is what are the extremities of latus rectum of this parabola? What are the extremities of latus rectum of this parabola? So this is our next question. So this is your figure. This is your origin 0 comma 0. This is a comma 0. Now if you remember the definition of latus rectum, it is a chord that passes through focus and also perpendicular to the axis. So since this point is a comma 0, here also since it is perpendicular to x-axis, here also the x coordinate is a, and even here the x coordinate is a. So and you have the equation y square is equals to 4x. When you substitute a here, you will get y is equals to plus or minus 2a. So therefore this is 2a, this is minus 2a, and these two are the points of your are the end points of your latus rectum, or the extremities of your latus rectum. All right. And what is the equation of latus rectum? Equation of latus rectum is simply x is equals to a. All right. And what is the length of the latus rectum? This particular length is 2a, and this particular length is also 2a. So therefore, the length of the latus rectum is 4a. And what is the focal distance? What do you mean by focal distance? So, focal distance is simply your SP. What is SP? So, we know SP is equals to PM. So, here PM is easy to find out. This is x comma y. This is x plus a is equal to 0. Then PM is simply mod of x plus a. So, therefore, this is your focal length. And the thing that we're going to deal with is we are going to find out the parametric equation of this parabola. Now, what is a parametric equation? So, the parametric equation is something where you express both the x coordinate and y coordinate of the conic in terms of some other parameter. Let us see how it is done. So, y square is equals to 4ax. So, if you substitute x is equals to 80 square and y is equals to 280. So, this substitution clearly satisfies the above equation where t is any parameter. T is any parameter. So if y is 280, so y square is 280 whole square is equals to 4a, x is 80 square. Here your left hand side become 4a square t square, even your right hand side become 4a square t square. So this particular substitution of x and y in terms of parameter t clearly satisfies your equation of the parabola. So therefore, this is the parametric equation of the parabola. Alright. So now we are done with the equation of the parabola as well. Now, this is not the only equation that we are going to deal with during our JEE preparation, but there are some other forms. So we have dealt with this form, y square is equal to 4ax. Alright, how does this look? This looks something like this. This is your a comma 0. This is your vertex, which is origin. This is your x plus a is equal to 0, which is your directrix. Alright, so the next form that we are going to deal with is y square is equal to minus 4ax. So it will look exactly reverse like this. So this is your vertex and the focus is minus a comma 0, and this is this is x minus a is equal to 0, which is your directrix. This is one more form that we are going to look, and these two are horizontal parabolas. Horizontal parabolas, because the axis of these parabolas are parallel to x-axis. Now we have another set of parabolas which are vertical parabolas. So the equations of those will look like this: x square is equals to 4ay. So this will look something like this. So this is your origin, this is your 0 comma a, and your directrix is y plus a is equals to 0. And the next another form is x square is equals to minus 4ay. So it will look something like this. This is your origin, this is your 0 comma minus a, and the equation of the directrix is y minus a is equal to 0. So these are the four forms of parabolas that we use in our JEE preparation. Alright. So for this particular thing, the parametric equation is simply minus 80 square comma, so x is equals to minus 80 square, y is equals to 280. You can substitute and check. So you should remember these things. And for this form, your parametric equation is x is equal to 280, y is equals to 80 square. And for this particular form, parametric equation will be x is equal to 280 and y is equals to minus 80 square. So with that, we are done with all the general forms of the parabolas whose vertex exist at origin. So there are two horizontal parabolas whose vertex exists at origin, and two vertical parabolas whose vertex exists at origin. So we are done with these forms. All right, and we are done with the parametric equations of these four forms. All right, so with that we come to the end of this video. But before we end the video, let us solve one good question based on whatever we have learned so far. Okay, so the question goes like this: a right angled triangle ABC is inscribed in parabola y square is equals to 4x, where A is the vertex of parabola and angle BAC is 90 degrees. If AB is equal to root 5, find area of triangle ABC. Alright. So now let us draw the figure. So y square is equals to 4x. So this is the parabola given to us. So if you compare this equation with the generic equation of the parabola, which is y square is equals to 4ax, you will get a is equals to 1. Therefore, your focus is at 1 comma 0 and your directrix is x plus 1 is equal to 0. So whenever you see the equation, you should deduce these two things. So let us draw the figure of the parabola first. So it looks something like this. So this is your vertex, which is your origin, and this is your focus, which is 1 comma 0, and here you have your directrix, which is x plus 1 is equal to 0. Now what are they saying? Right angle triangle is ABC is inscribed where A is the vertex of the parabola. So therefore this point is denoted by A, and they are inscribing the right angle triangle in this particular parabola. So let's say it looks something like this. All right, so this is B, this is C, and this particular angle is 90 degrees. That's what they told us. And it is also given that AB, this length is root 5. All right, all right, so this length is given to us. Now what do we have to find out? We have to find out the area. So since this is right angle triangle, area is half into AB into AC. All right, we already know AB. So now to find out area, we have to find out AC. But how do we find out AC? So let's see. So let us say this point B is, so we know the parametric equation. Parametric equation is 80 square comma 280. All right. So since A is equal to 1, so we can write for this particular parabola the parametric equation as t square comma 2t. Let us say this point is t square comma 2t. And let us say this point is, since we have already used t here, let us say this is t1 square comma 2t1. All right. Now we know AB is equal to root 5. But we can also use the distance formula to find out AB, because we know the coordinates of A and coordinates of B. So it is simply t square whole square plus 2t whole square. This is equal to root 5. Squaring on both sides, we get t power 4 plus 4t square is equals to 5. So this is t power 4 plus 4t square minus 5 is equal to 0. So this can be written as t square minus 1 multiplied by t square plus 4. So t square plus 4 can never be 0 because t square is always positive. Therefore, t square is equals to 1. This is the only solution. So your t is plus or minus 1. So since this B coordinate exists in first quadrant, we only take t is equals to 1. So this point is 1 comma 2. And So we only considered t is equals to plus 1. So we got this particular point. Now what is our task? Our task is to find out the point C as well. How do we do that? So we know that slope of AB multiplied by slope of AC is equals to minus 1. Since those are perpendicular to each other. What is slope of AB? It is simply 2 minus 0 upon 1 minus 0, which is your 2. And what is slope of AC? That is 2t1 upon t1 square. So this is minus 1. So this t1 and this t1 gets cancelled. So this t1 goes here and you'll have minus t1 is equal to 4. Therefore t1 is equals to minus 4. So therefore this point will be 16 comma minus 8. Alright. So now we know this point and this point. So this length is root 5. We can find out this length AC. AC is simply root of 16 square plus 8 square. 16 square is 256, 8 square is 64. That is simply root of 320. So therefore area is half into AB is root 5 and AC is root 320. And if you solve this, you will get the answer as 20. So that is the area of your triangle. So I hope you have understood how to use the equation of parabola and solve the questions. All right. So I'm going to add lot of quiz questions here to, for you guys to check your understanding of whatever you have learned in this particular session. So if you like this video, give it a thumbs up, share it with your friends, subscribe the channel for more such content, and we have more episodes coming up for Parabola. So we are going to go all the way till JEE Advanced level. All right. So with that, the video comes to an end and I'll meet you in the next video. Till then, take care and bye bye.